So hopefully now you will all recognize me as being a familiar face in the crowd. So I am a participant, but I've been undercover also as one of the speakers, unbeknownst to the majority of you, I think. I think Marta did mention it on the first night. So I am here to talk about Git workflow. This is something that Anshu wanted me to address based on a collaboration or my participation in helping to develop the Flash code in terms of the new version Flash 5. So as we started working on this as a team, we started using GitHub and we had interactions. We collaborated through that software and started to realize that eventually we had enough people, enough challenges integrating our code together through the version control system that we needed to start adding on complexity. And so we started working together to design a way that we could collaborate together through GitHub in successful ways. And so I want to acknowledge, first of all, that clearly that work is not just mine, and the understanding that I'm going to present through this is also based on discussions that I've had and collaborations that I've had with other people who work in the Flash Center. So namely Anshu, who you've already met, Klaus, Sarab, and Carlo. And it's also, my understanding of Git workflows is also developed through discussions I've had with my office mate, Julian, who's a software engineer at Argonne. And he's been very kind and shared with me the different workflows that he's used through the projects that he's involved in. So as I mentioned, the idea is that as developers and as members of a development team, we realize now that version control is a very useful and successful tool. If we use it well, we can be very productive, and at the same time, we can ensure that we are creating correct code. At the same time, we also realize that that's very challenging for us to collaborate when we're developing in parallel and perhaps distributed across the globe. It's very challenging for us to do that via a distributed version control system. And so as we give this talk, which is really going to be more of a conversation, I hope that we start to develop an understanding of what those challenges are and how we can actually use the version control system and work together as a team so that we can overcome some of those challenges. And so one of the things that we're going to do is we're going to explore really sort of this notion of extra dimensions of distributed version control system and version control systems. What I mean by these extra dimensions is, for instance, when you are using a distributed version control system, you have this notion of a local repository that's existing on my laptop. And then you also have a remote repository, which might be someone else's laptop, or it might be, for instance, GitHub or GitLab, if you're hosting your repository on one of those services. Another dimension that we have is, for instance, branches. That's not particularly distributed version control, but that is one of the nice aspects of using something like Git. Branches are easier to manage with, and so we should try to really use those to our benefit. And finally, I won't talk about this too much, but if you are hosting your software out of something like GitHub, they oftentimes provide you with an extra layer of collaborative tools. So for instance, issue tracking, pull requests, and you can also trigger formal code reviews and actually encode the results of that code review within GitHub itself. So I won't talk about that too much because that's would be stepping on the toes of the talk that's following mine. But if you are familiar with this topic and you, as we go through these different slides and these different examples, please feel free to try to imagine how you could incorporate those into these workflows. So we're going to just start off. We're going to just be working through a series of examples, starting off with something that's simple in quotes, and then building up to more complex examples. Hopefully, as we go through this and we work through these examples, we'll come to a common understanding of really what are the particular aspects of these different workflows that we should have in mind as we're evaluating or designing workflows if we choose to adopt such a thing for the projects that we're working on. So as Anshu mentioned, in general, it seems that the ATPETS participants, you all have a fairly good understanding and management of Git, or you've been exposed to it to varying levels. As such, I've decided to design this talk to really not get into the particulars of Git, to not make this a particularly technical talk. In general, I've tried to really leave everything at a higher conceptual level, and hopefully if there are people who don't have as much experience with Git, by making that decision, hopefully you'll still be able to follow along and appreciate what a workflow is and how you might use it. So we'll start off with our first example. We're going to imagine that there's this new development team that's been put together consisting of Alice and Bob. They're going to start working on a piece of software that they inherited, and they're going to be collaborating through Git. So at some point in time at the beginning of the project, someone will have put the existing software in this remote repository, so let's say on GitHub. And that consisted originally of 3 different versions of the software. So the initial software was commit A, this little open bubble. Then someone made some changes, determined that that was the next version of the software, committed it as B. And then finally, someone made another change and put it into the system as commit C. And so those little open bubbles are the commits. The branch is really linking them together to show that that's sort of this linear development history that they've had so far in the software. And we'll then assume that Alice is sitting in some part of the world at her laptop. And she decides to issue a clone command from her laptop via Git to that remote repository, at which point her system will actually take that full repository that's sitting on GitHub and establish it as a separate but full repository on her machine. It will also synchronize her machine at that point so that she will also have commits A, B, and C, just as the remote had. Simultaneously, Bob's sitting someplace else in the world. He does that same thing. He issues a clone, and he gets his own version of the local repository. So he has commits A, B, and C. In other words, we have 3 independent repositories that are linked together and at this point in time synchronized. So Alice and Bob, being eager developers, they immediately sit down and start getting their hands dirty. So Alice, in her repository, starts working on some tasks and makes commits D, F, G, and I. Simultaneously, Bob starts working, and he's going to make commits E, H, and J. So at this point, we now realize that these 3 different repositories, while related, have diverged a little bit. And this has been powerful because each one is sitting in their laptop in a different part of the world, and they're developing independently. But that's not the point of a collaboration. They need to start intermixing their code, and they're going to do it for the purpose of this example in this remote repository origin. So they need to now synchronize, sort of take the effort that's encoded in their local repository and share it with this remote repository so that the other collaborators can see it and so that users of the code can go and build their software off of this origin, this remote repository. So we're going to be talking about throughout the bulk of this is how do they integrate the different changes that they've developed independently through the version control system. So when you do this type of integration, there's going to be a race condition in general. So we're going to imagine that Alice is the first one. She finished her commits D, F, G, and I first, and she decides to go and push those to the remote repository. In other words, she's ready to share those commits with the rest of the world and with Bob. And because all she did was add on new commits to that chain of master, this should be simple, easy, painless, low risk. What's going to do is the version control system is just going to take those 4 commits, pass them to the remote, and then those are just going to get appended to the version of master that's in the remote. So that's easy, and at this point in time, she has now synchronized her local repository with the remote, which means that there's no longer a divergence between those 2 repositories. At the same time, Bob is sitting here, and he does not know that Alice has done that yet, but he has the every intention of integrating his code as well. So to make this example a little bit more spicy, let's imagine that there was a little bit of a lack of communication between the 2. They were new to the project, they were really eager to get there, and the first thing that they notice is that there's this loop CPP that was sitting originally in that commit C. And I don't know if you can read it there, but all it has is 2 comments that say, to do, please write 2 very important loops. And so they jump in, they're very eager. Alice starts to write those loops in commit D. Bob does that and commits E. And you can imagine that it's very unlikely that they both would have written that code in an identical manner, which means that there's now a conflict in the system between these 2 versions of loops.cpp. So Alice, she's fine. She got her commit into the remote repository. However, Bob, when he tries to push his changes, the version control system is going to recognize that there's this conflict, throw up its hands and say, I don't know what to do. You're going to need to intervene. And poor Bob is going to have to sit down and start analyzing, looking at these 2 versions of loops.cpp. So at line 38, you'll recognize that those 4 loops, they're different in a very trivial sense. Someone used a ++i, someone else used an i++. Bob shouldn't have too much of an issue with that. He can very quickly resolve that conflict and move on with his life. However, at line 43, you'll see that there's a non-trivial difference. They're iterating over the same number of elements, but one is 0-based and one is 1-based. So we're going to hope that Bob is going to be a little bit more conscientious and rather just assume that what he did was correct. He'll actually check his code and make sure that there's no bug. Then actually look at commit D and make sure that there's not some important logical difference that he's missing that led him to actually perhaps write the incorrect code. So he'll make sure, in other words, that perhaps this is a bug before he tries to resolve that. Clearly, that's time-consuming. It also means that Alice and Bob are probably going to have to sit down and talk to each other in order to resolve this issue correctly. Because if you don't, and if you try to jump through and do this conflict resolution quickly, it's entirely possible that at this point of resolving an integration conflict, you might inject unintentionally a bug into the code. So that's where we really start to dig into this difficulty of collaborating through integration in a version control system. So this is our first workflow. Congratulations if this is the first one you've ever seen. According to Atlassian Bitbucket, at least, this is known as the centralized workflow. It's simple to learn and easy to use, in quotes, because if you're new to Git, and if you're new in particular to working in these large development teams, this is still going to be a little bit difficult to first learn and to gain some confidence in using. But in terms of all the workflow examples that we're going to see here, it is perhaps the simplest and the easiest to use. So what do we like about this? Well, we are really leveraging that extra dimension of using a local repository and a remote repository. We're all working independently in our own repositories. That's great. And the integration is only happening when I try to synchronize or link my local repo to the remote repo. But one of the things that we can think about as we evaluate these workflows is, for instance, how does the productivity related to adopting this workflow scale with team members? So if it's just Alice and Bob, that might be fine. But if now there's 10 people or 20 people on this team, what happens when I try to push my results to this remote repository? Maybe I'm going to find out that I have 5 different merge conflicts or integration conflicts, not with just one developer, but with 5 distinct developers. And therefore, I'm going to have to sit down with 5 different people before I can finish this integration step. So this simplicity that you get, this low overhead, might not work in that sort of a situation. Another thing that you can imagine is perhaps you have a development team where most of the people are accustomed to synchronizing their local repository to the remote repository on the order of, let's say, once a day. But there's one person who decides to just write in their local repository for a month long and then share it at that point. Well, by then, their local repository, their version of the code has diverged significantly from what's in the remote repository. And therefore, it's very likely that they'll have some sort of conflict, and even more so that it will be difficult to resolve that conflict correctly. One of the ways that you can perhaps get around some of those difficulties is if you can really structure your team and the way that you partition the work amongst the team members so that every single person is working on a different portion of the code, different files, well then you know a priori that you're never going to get any merge conflicts. So if you're lucky enough and you can actually do that, you really might be able to get away with this level of simplicity. So one of the things I also want to mention before we move on to the next subject is that in this case, we were always working on the master branch, right? All of the changes that we were making were directly in this linear history of development. And that might be okay, but the reality of coding is that you might not have a choice. Every now and then you might need to check something in, and you might know that the code is broken. So you might have commits that are functioning and commits that are not functioning, which is not necessarily bad, but if you can imagine that users just come in and use your repository, and for whatever reason they don't want to just check out the latest and greatest commit, but they want to go back in the development history a little bit, you have to have some way to communicate to them that a specific commit is broken. So you could do that, for instance, through your commit messages. You could use tags. But I think that as we develop up workflows, we're going to be a little bit more ambitious and endeavor to create something a little bit better. So keep that in mind. We like master, we want to keep all the commits on master clean. So the second dimension that I mentioned is branches. So at the conceptual level, let's just define a branch as an independent line of development. We already saw one, which was master. But we're going to add on a separate class of branches called feature branches. And here the idea is that we want to use these to, as I suggested, protect the master branch somehow. And so as we're developing, we're given certain tasks that we want to perform or to changes that we want to make in the code. And so we're probably going to break those down into little steps. At each step, we're going to make a commit. And so what we can do is rather than just stringing those commits along on master, we're going to package up those commits because they're related and encapsulate them in the form of an independent line of development known as a feature branch. And so that's what you see here in this graph. We had the master branch with commits A, B, and C. And at some point, someone needs to implement feature A. So rather than doing their work on master, they're going to go to Git and create this new feature branch called feature A, which is based off of commit C, the latest commit on master, and start doing their work in the forms of commits D and E. So that's all well and good. They've done that independently, but the idea is they want to actually merge this in back to the master branch to express to everyone who's using the repository that that feature A is actually now implemented and ready for use and correct. So when you create a branch, in the end, you're always going to merge it back in somewhere, hopefully into master. And so in this particular case, everything is nice and easy. We call it a fast-forward situation, because while I've drawn it with this dog leg to emphasize the fact that it's a branch, in reality, it's still just a linear history of development. And so what Git will do is just take those commits D and E in the feature branch and stick them down on master so that I get that sort of flattening out of the branches. However, you can imagine that this can happen, this sort of lamentable situation can happen quite often as you're developing. So same person comes back, they make a feature branch off of commit A in this case and do work B and D, but in parallel, someone did some development and put a new commit C on feature A. So this is where we really see the name branch coming about. And so I don't have a fast-forward situation. I can't just sort of stick those at the end and at the end of the master branch. The version control system is actually going to have to take the contents of B and D and mix them successfully with C. So if I did have a merge conflict, again, between B and D, that would have to be resolved by the version control system and by manual intervention on my part. The end result of that is that you would create what's called a merge commit here on E. So those integration difficulties are coming at this point of merging of branches. So once we get branches, we can really start doing powerful things, but with that great power can come great complexity, and you could start to make some sort of squirrel's nests of branches going on through collaboration. So that might be good for your development style and the way that people like to work, or it might end up becoming, the complexity might end up posing sort of a counterproductive level of overhead and difficulty. So you might want to start thinking about coming up with workflow policy or rules. So a standard one that I think almost everyone adopts is that you don't want to have branches named A, B, and stuff. So really, what's nice about using something like GitHub, the graphics, and all of the things that are there is that it really is a way for developers to communicate with each other. A, B, and stuff is not expressive. I'd like to just look at this graph and immediately know what are the commonality between these different commits on it. What are people working on? So for instance, that original example, Bob and Alice were working independently and they weren't sharing everything. So we could imagine that, for instance, they just started working on that same code. They duplicated their effort. That's not productive. Whereas if they were sharing things, they might have seen immediately that Bob had started working something, and so Alice can spend her time on something else and be more productive. Another thing that you can ask yourself is, do you really want to make branches off of other branches? Is it okay for someone to take branch A and put it into stuff? In particular, imagine in the situation where A is one developer and stuff is another, and this person developing on A just thinks that this person should have A and stuff and just does it without communicating with them. Well, that can cause both technical and some sort of social difficulties. And you might, well, depending on your team, you might want to start reining that in with some level of workflow policy. So now let's take branches and use that to extend the centralized workflow example that we had. We're going to imagine that at some point in time, this remote repository only had commits A and B at the beginning. And Bob goes to his laptop and synchronizes his local repository so that he has A and B. And he immediately starts work on a feature branch, a sensibly named one, issue 151. He's working with an issue tracking system. And he does work in the forms of commits E, H, and J. At some point, someone adds a commit C to the remote repository, and subsequently, Alice synchronizes her local repository and begins creating her common sensibly named feature branch, add solver A, in the forms of D, F, G, and I. So what we can see immediately is that Alice is in a nice situation. Her master branch is like the master branch in remote, and her feature branch is in one of these nice fast-forward merge situations. However, Bob is in another difficult situation. If he were to look at the remote repository, he would mean that he would know that he's got this simultaneously developed branch and that he's going to have issues. So through this race condition, we're going to imagine that Alice in her local repository does that fast-forward merge onto her local master and then pushes it. Again, she won the race condition, so there's very little difficulty associated with that. Those D, F, G, and I are just going to get transferred down to the master here, so her local repository is again synchronized with the remote repository. Everything's happy, no risk. However, Bob is going to go to his master branch and pull from the remote and suddenly find that there's 5 new commits. So he's got some issues. And for the purpose of this example, let's again imagine that there was that conflict on commits D and E. And so he's going to have to do some level of conflict resolution when he does his merge. So Bob is lamenting the fact that he can't do a fast-forward merge. He loves that. Everyone does. So he's going to do the next best thing in this particular case. This is not something that you have to do, but it is something that can be done. And so he's aware that there is this command called rebase. Has anyone heard of rebases before? Okay, we got a lot of people. Okay. I was not expecting that. So essentially what the rebase is going to do is take this feature branch that Bob wrote, which was based off of this old commit B, and he's just going to issue that rebase command, so it's going to slide it down and rebase it off of the latest commit on master, which is I. By doing that, this is now in that lovely fast-forward condition. He loves that, but nothing's free in life, right? The problem is you'll notice that these are E, H, and J, and these are E prime, H prime, and J prime. They're not the exact same thing. The idea is that this E prime is reestablished by the rebase based on the contents of E and all of those other commits on master that you slid past. So there will be that conflict between let's say, E and C or E and D. That's going to get caught by the rebase command when it tries to establish that E prime commit. It's going to stop what it's doing, alert you to the conflict, and ask you to intervene manually to resolve that conflict. But once you're done with that integration, you really are in an amazing situation, because now not only are you in that fast-forward setup, you can also go to that commit J prime and run all the tests that you want to know that, first of all, your issue 151 is working, but also that issue 151 is working with and compatible with those changes that Alice made. Once you're in that state and you have confidence that what you've done is correct and ready for master, you will merge it in and push it to the remote. Yes, sir?
So potentially commits H prime and J prime could have different conflicts with I that E prime didn't?
Well, OK, this is going to get complicated. So say that again?
So you mentioned that you have to integrate E prime with I. There might be merge conflicts.
Well, so you would integrate E with C through I.
Yeah, E with C through I, but then H and J might have different conflicts that E didn't have. So you have to then integrate E, H, and J all the way through? That's
right. At every step, it's a rebase, I believe, is going to go through in sort of a sequential order. And at each rebasing of each of these commits on your branch, it might stop you, and you might be forced to intervene. So what do we like about feature branches? In particular, why do I want to add on this extra complexity of using branches? Well, the reality is that it's nice to have different lines of development because we have different developers in the team. We don't want each other getting into these conflicts. But at the same time, the reality of development is that I'm not normally working on one line of development. I might have one task to do that's going to take me a month, say, to add a new solver. But in the middle of that effort, a bug might pop up, and I need to actually resolve it. So rather than mixing those two works together on one branch, I'll just create a new branch for that bug, right? So that the reality of my work is in these independent lines of branches, and I want to use the branches to accurately reflect that and to really separate those different unrelated tasks. So that's one thing I gain. Another thing is that if I'm not only a developer but also a user, I might want to maintain my master branch up to date at every point in time so that I can build the latest and greatest version. Because I'm not actually developing on master, I can just constantly synchronize my master branch to the remote and get that and use that. And the only time I ever interact with the master is just at that point of integration, which is few and far between. So we like the integration with rebase. It's nice. It's actually fairly safe because it's being done on the local repo and not that common centralized repo that everyone's working off of. And the other thing that's nice about rebase is that if the conflict resolution is going horribly wrong, you can actually abort it. Stop what you were doing, pretend that it never happened, sit down, regroup, and attack it in a different way. That's something I've had to use multiple times. I'm very happy about that feature. So rebase is an advanced Git command, which can be a problem. So rebase can cause pretty serious complications if you don't use it in the correct way. So the community seems to have certain rules about what you should and shouldn't do with a rebase. And so if you want to use rebase, you really should read at least this documentation here that I've linked to. The downside to that reality of rebase is that if you have new members coming into your team who are not particularly fluent with Git yet, Well, the fact that you've based your workflow out of based on an advanced command poses a very high barrier that someone has to get over. So you might want to avoid something like that. Another reality of these centralized workflows is that you're actually hiding what you're doing. So Bob and Alice were working, let's say, for a month long, and one didn't have any idea of what the other one was doing. That's not particularly good. We're really missing this possibility to communicate through the version control system. Another reality is that when we're doing those fast-forward merges, we're making the feature branches disappear. It looks as if the development of this software is clean and linear, which is not necessarily the case. And depending on how you work, you might want to actually have this development history reflect the reality of the development process. So that's not good. And the other thing is, if you are really developing on the scale of a month, let's say, before you check in with the remote repo, well, you're missing out free backups on some remote system. Right? You put a lot of effort into those commits, you might as well get them someplace else. I'll point out that we introduced branches to try to protect master, but we still haven't done that yet. If I write a commit on my feature branch that's broken, when I flatten out through that fast-forward merge, that broken commit still gets into master. So we've still got some work to do in terms of achieving our final goal. So to do that, we're going to introduce a new class of branches known as the infinite lifetime branches. We've already seen one of these in the form of master. For all intents and purposes, that branch is going off in either direction in infinite time. What we can do is actually just replicate that in the form of a new branch. So for instance, development or pre-production. Practically speaking, we would go back to some commit on master, where we know that the code is functioning and working. We would just create a new branch from development, and as we commit to it, we would just never delete that branch, nor would we ever permanently merge it into another branch like development. The reason that we like these is that we're essentially encapsulating a particular characteristic or commonality of the commits that are on that branch. We're creating a very specific development environment. So for instance, if I have a branch that's called development, I hope you can all sort of intuitively realize that these commits probably can't be trusted. Some of them might be prototyping, some of these might be earnest developments that will end up in master, and some of them might just be complete garbage. So the idea is here, this is where you get to play around. Whereas if I have an infinite lifetime branch named pre-production, well, that just by the name sounds completely different. The idea is that I've done some work, I've got a group of commits that I believe to be correct, and what's more, I believe that that functionality is interesting and should be put into master, right? So hopefully we're getting an idea of that. At this point now, we're also going to make a change. We're not really going to be working in a local versus remote repository sense. We're going to imagine that as you make a commit, you should feel free to push that to the remote repository. In other words, everyone's going to have a master, everyone's going to have a development on their machine, and the feature branch that you're working on, everyone will see those as well, even as they're in development, even if you haven't finished that feature yet. Just go ahead and feel free to share it. If you look at this graph now here, you'll see that there's two feature branches that are being done in series in this case. And you might be able to work back to what are the rules of my workflow policy that are being imposed in this repository. So for instance, you'll notice that the feature branches all start on master. They all merge into master. And the other reason, another rule is that before I merge into master, I need to merge into development first. And so this might be a point, so I understand that there are probably people who are sort of rules averse. They might say, why are you trying to really constrain the way that I use this version control system? Why don't you let me use its full functionality, which is a perfectly valid question. Well, the idea is when I put in these rules, I end up getting these nice, simple, reproducible patterns. I'm really reducing the complexity. And when I reduce that complexity, I can start to make well-defined statements, such as, I hope you all understand, that every commit that's in master is also in development. That means that master is a subset of development. That means that when I'm doing this sort of action, I'm taking these two infinite lifetime branches and synchronizing them so they can't diverge in any serious or significant way. Yes?
So you just said that every commit that's in master is also in development.
Correct.
So then is every commitment in development also in, because you don't have that there.
Well, so there's a couple situations that can happen. Is if you imagine in time, before they do this merge into master, there's this commit on development. But it will get to master, hopefully, unless they abandoned it. But what can happen is precisely that someone gets something on development and finds out that it was a bad idea, and then it would just sit there forever. So there could be a divergence. You might just be able, depending on what this commit is, you might just be able to leave it there, or you might actually need to fix it up. So there'll be a slide about that a couple down. Unless do you have a follow-up question? Or? Okay, so when I get to a slide that says bad idea, if I haven't answered your question, just re-ask it. So in this particular example, it's a little bit too simplistic. There's not really any integration happening because it was all done in series. So if we up the ante a little bit and start to imagine that those two feature branches were based off the same master and developed in parallel, we'll again realize that there's a race condition. So whoever developed issue 151 is footloose and fancy-free. They get into development, they get into master, no issues whatsoever. However, with add solver A, when they get to this commit and they try to merge into development, well, now they're going to find out that there's a conflict. The reason we know that's going to happen is because, again, everything that's in master is also in development. So development has that issue 151. So what we've done is push that integration problem off of master and put it onto development. So we're isolating master a little bit. And so in this example, the way I've drawn it, the idea is that they merged into development, found out there was a conflict, and found out there was an incompatibility between those two features. They fix it with one more commit, put that in development, and put that into master, and everything is solved. So the next level of complexity is the current workflow that we're actually using for Flash 5. I emphasize the word current because we actually started off with that feature centralized workflow. That was perfectly fine. At the beginning, there were only 3 people developing, and we were all really developing in separate parts of the code. So it was perfectly functional. We love that simplicity. I miss it, in all honesty. But we got more people working. We started stepping on each other's toes. And so we started brainstorming and talking with other people to see how we could grow up our Flash 5 workflow. And this being Flash 5, we're going to have it motivated by testing, which leads into my afternoon talk to some degree. So what we have here is an infinite lifetime branch in the form of development and a new one called staged. We have the same set of rules. Feature branches go off of master and merge in. Before you want to go into master, you first have to do integration on development. Once you're happy there, then you merge into staged, and then from there you can go into master. So the idea is when you go into development, you're going to integrate, you're going to do whatever tests you need to do to convince yourself that what you've done is correct. Perhaps just sort of looking at locally at the functionality. And then when you believe that that functionality is interesting and clean and ready for the master, you put it into staged. And there we would normally do some full set of automated testing to make sure that there wasn't some subtle bug that you missed. So that is here we really are protecting master. So if we look again at this race condition, we see a similar setup. Here dev 1 gets in. Development 2, we're getting that integration again. So they had to fix up their code on dev 2 due to that conflict, and then put it back and then put it into those different setups. So what we really understand conceptually is that development is the Wild West. That's where the integration is happening. That's where a lot of unfortunate stuff could go wrong down there. And then staged is really this extra buffer where we are staging potential code that should go into master. It should be cleaner, but it might not be still. And we're really going to do that full testing so that hopefully what I've convinced you all is that within the scope of our testing, the testing suite that we're using, every single commit on master should be correct. Yes, sir?
So in each of these stages in the development and the staged branch, if you find that there are things that you need to fix before you go to master, do you then propagate those adjustments back down to development, back through stage?
Yeah, I've got a slide about that. So one of the things I said about current is that we recognize that this might not be perfect. It's working for us right now. But there are things that I don't like, which is exactly that. Once I create one merge conflict, I create it on three branches, right? So I'll show I think we'll have time to get to it. I'll show how you might resolve that. So for people who don't like rules or who think that I've been fairly severe in creating those rules on that workflow, why might it be a good idea that you always base your branch off of master? So let's imagine a scenario where someone's created a branch, someone's put a feature here, and some developer likes that feature. So they're going to want a shortcut. Why do I want to go to master? Master doesn't have that new feature. Why don't I just jump ahead and base my work off of that nice effort? Seems reasonable. So let's imagine now that someone comes in, they base their branch off of master, they like that, this is a verified commit, they start doing a few commits and put it in development, and surprise, surprise, that was a bad idea, as the branch name foretold. So they abandon that development. They just leave that branch sitting there. They never merge into staged or into master. So this other eager programmer comes in and sees that there's this new feature that's sitting on development that they like and they want it. It's not in master yet. Let me just jump ahead and base my branch off of that. They do 3 commits. They put in develop, merged, and staged and master, and they're happy. If we trace back this history, though, we see that this merge commit contains the 3 commits on good idea, which we want. That's great. They contain that new feature, fancy feature that's on development. That's great. That's what I intended as well. However, I'm also going to pull in bad idea. So that feature that was never intended to get into master got pulled in because I based my branch off of the integration environment, which is the Wild West environment. So by having this rule of going off of master and ending in master, we are effectively isolating master from that integration environment, which can be powerful. So now this is what you are talking about. The idea is, again, a race condition. Someone makes dev1, gets it through those 3 branches. Dev2 alters that exact same code and creates a conflict here. But it's also in development, staged, and master, which is a nightmare. Why do I've just propagated conflicts in a very unfortunate way through all these branches. So how can I possibly deal with that? So one of the ways that I've seen, I'm still struggling with trying to find the best way to deal with this. I don't like this solution. I've seen people mention it on web, so people do this. I know that people in Flash 5 do this and have not had any problems with it. But what you can do is actually take that commit on merge that contains that dev1 development and merge it into dev2. When you do that merge, the version control system should detect the conflict. And you fix the conflict on your feature branch, right? You wouldn't want to merge in the other way. The guy's master is flowing into yours. You address that conflict here. You fix it, hopefully, and then you commit through. So, yeah, go ahead.
I guess I was, and I know this is different than the local versus the master, but I always thought it was correct process to always do a pull and a local resolution before you pushed. Is that not true? I mean, maybe that was just.
Well, so you would be doing this. That's a very great question, because you would be doing this locally in your repository, right? So you would try to resolve this here. And if you find out, for instance, you could actually merge into development locally and not push that merge to the remote yet. And you could actually find out that things went horribly wrong here and try to undo that merge on development and try to figure out how to work as well. So you still do. That was a good point. I didn't estimate that. Even though we're still committing everything to the remote constantly, we're still using leveraging that idea that we have a local repository.
I guess what I would do is I would pull from the remote dev,
okay,
and then merge and resolve conflict, and then push to remote, and then pull from remote staged.
This might be something where we need a graph. So if you want to talk about this afterwards or during the evening, I'll be around. I'm here all week, so we can discuss that that interesting issue. The first time I ever looked for Git workflow, let's say a year or so ago, this is the first image I came up with. It's from a 2010 blog entry by Vincent Dreesen. My understanding is that it's a fairly widely used and accepted workflow. In fact, I believe here other people on GitHub, you can find that they have Git extensions. So this is called Git Flow, and these extensions allow you to go to the command line in your repository and enter Git Flow, and then enter some subcommand. And that will somehow, I think, check the state of your repository to make sure that people are adhering to the workflow. So I started reading this blog a year and a half ago, and I realized after 30 seconds that no, I don't want to know Git workflow to this level. This is entirely too complex. After having gained some experience with it, I just sat down with the drawing and just started looking at it and trying to reverse engineer the actual rules that they have, and now I've come to appreciate it. It is really quite nice. What we see here is that we have some infinite lifetime branches. We have master, of course, and we have development, right? We notice that master has very few commits on it, and we notice that those commits are coming from something called release branches. So immediately we understand that this complexity and this workflow is related to the fact that this software is developed and deployed with a regular sort of release schedule. So if you don't have that, if you don't want that complexity, then perhaps you don't need to use this big of a workflow. Another thing that we'll notice is that the feature branches are being pulled off of development and merged into development rather than in master. And this is something that people, I've read online that people complain about this. The idea is, again, you've set up this whole workflow to make sure that every commit on master is correct. Why don't I base my feature branches off of something I know that's correct? If I'm going to go off of to develop, I need to make sure that my workflow has certain rules in it that really keep these two infinite lifetime branches well synchronized so I'm not wasting my time on those feature branches, right? And so
it seems like this has been something that...
one of the nice things that you could do to try to understand this, I don't think there's much point in going into it, is try to figure out what those rules are to keep those two synchronized. And also, as before, in the last case, you might want to consider where are the merge conflicts occurring and how in the world would you resolve those. So there are more workflows. Scott Chacon wrote in 2011 his own blog post about GitHub flows, more of a response to that previous one, the Git Flow. He more or less says we're using continuous deployment and continuous integration, therefore we don't have that formal release schedule, and we can come up with a much simpler workflow. GitLab flows, they have a couple other examples with some advanced techniques that I appreciated. So you can go to those links if you would like. Conclusions, sort of echoing, we love version control. Collaboration's hard, let's use workflows to make that easier. Be productive and have correct code. Echoing what Anshu said is these workflows are just examples. You don't have to use them. If you do decide to improve your workflows, what you can do is sit down as a team, consider your culture, consider the difficulties of the project that you're working on, come up with rules and assess whether or not they're feasible or acceptable for all the team members. And of course, this I've seen echoed over and over, is start with the simplest, gain some experience with that. If you find out that it's just not working for you, then add complexity on only where and when necessary. So that's the end of my talk. Thank you for your attention.